So let's begin that. The 5.6 points of concurrency. Once again, I already discussed what exactly these are. So let's go ahead and go through the constructions for them. Okay, so the first is the incenter. The incenter is the intersection of all the angle bisectors of a triangle. All right, so in the sample problems in your text, and there are little triangles there for each of these if you want to do constructions and follow along with me. And at the very least, you can sketch along with me what it takes to complete each of these constructions. Okay, let's start with the incenter. If you have this, and your construction tools, the incenter is found by performing all the angle bisectors. So if you recall from our constructing an angle bisector involves placing the compass tip on the vertex, constructing an arc that passes through both sides of your angle. Then from each of those intersections, we're going to create an arc in the interior of our triangle. Now, if you want, you can adjust your compass at this point, but there's no reason to. And so really what I did right here is basically the rhombus method. And if I were to connect these two intersections and then the intersection of these green arcs, that would form a rhombus. Okay, however, if I connect it and draw a straight line back through our original vertex, I have my angle bisector. Okay, so we're going to repeat this at each of the vertices. Okay, so construct an arc that passes through both sides of our triangle from each of those intersections. Construct an arc in the interior of our angle. And when I do this, my intersection can then be connected back through my original vertex, and the point where those intersect is my incenter. Now, do I need to construct the third angle bisector for this construction to find the incenter? No. Is there an advantage to doing it? What is the advantage to constructing a third one if you have time? Nathan? Right. It's simply to verify, right? So if we bisect this third angle, our expectation is the angle bisector should pass through this same point. If it doesn't, then I've made a mistake somewhere. So if I construct my arc, again from each of these intersections, and then connect that back through my original vertex. Okay, does it confirm what I was expecting? Yeah. So here is my incenter. So this intersection right here is the incenter. And now you might be asked to just locate the incenter. The other thing that you might be asked to do that involves this exact same construction is to construct an inscribed circle, or a circle inscribed within the triangle. And so what that means, again, this incenter is the center of a circle that, when drawn, will have each side of the triangle tangent to the circle. Okay, so in order for us to do that, we know that this is the center, and we know that each of these three sides is going to be tangent to that circle. So what relationship exists between the tangent to a circle and a circle that might allow us to construct this circle? Tangent and the radius of a circle intersect at what? At a perpendicular or right angle, right? So if we construct, as a second step here, to construct an inscribed circle, what we're going to need to do is to construct perpendicular from the incenter to any side of the triangle. Okay, so I'm just going to choose the bottom side. If you recall from the methods on constructing a perpendicular through a point that's not on a line, the construction involves the following. You place your compass tip on your point that falls off of the line. You're then going to construct an arc that passes through that line in two places. From each of those points, you're then going to construct an arc. And the intersection of that, when connected back to our original point, will be a perpendicular. Okay, so if we were to draw in our perpendicular from the incenter all the way through this point, okay, the part of this that we are interested in is just the part that goes from the incenter to this side. And that portion is the radius of our inscribed circle. And so we can confirm this as our final step. The confirmation involves placing our compass tip on the center, measuring the distance of this radius, okay, and then we can construct our circle to confirm. And so when you look at this, what do we notice about that circle? Is it inscribed within that triangle? Meaning, are all of the sides of this triangle tangent to the circle?